Hello everyone. So in the next question we have given in today weekly contest 459 is count number of trapezoids, right? So as you can see, we have given this example and you can understand the number of trapezoid, right? So what we have given, question is saying that let me zoom a little bit more. Okay, so the question is saying that you are given a 2D integer array and that is called points. So you know the points are there, right? You know the coordinate system where the points we have given, the coordinates, like let's suppose x and y we have given at a given index. So let's suppose very first point 1 we have is 1 0. So if you see here, right, so 1 0 means at this line this is the 1 0, right? Similarly we have another points we have, like let's suppose 0 2, right? Then at this point what we have is it's meets here, right, 2 2, and what we have here is 2 3. Can we say that like that we have given? Okay, so as you can see, sorry, 3 0 we have given. So 1 0 2 0 3 0 2 2 and 3 2 we have given. This is 3 and this is 2 3 2 and this is 2 2, right? And this another point we have given is 3 0 1 0 2 0 3 0. Then we have given what, 2 2 and 3 2. Can we say that? So all these points we have given here. It means what it trying to say that you have given 2D integer array that is called points like this, and it represents the coordinates of ith point in the Cartesian plane, right? A horizontal trapezoid is a convex quadrilateral with at least one pair with the horizontal side. Means as you can see, horizontally it matches, right? These and these and these are matching. Okay, so that is why it is called a trapezoid, or horizontal sides with the parallel to the x-axis, and that is happening here, right? So two lines are parallel if and only if they have the same shape. So you know the trapezoid is you can say is a four side flat shape, we can say, that is called trapezoid with at least one pair should be parallel. So these and these lines are parallel, we can say, or these line and these lines are parallel. So these sides are called the base of the trapezoid, and the two other sides are called the legs, or what you call lateral sides, we can also say, right? You can, if you Google that, you can understand what the trapezoid, if you have forget that, right? Means the parallel sides are there, base are there, legs are there, attitude is there, right? So that things we have given. Coming to the question is saying that you have given the points we have given, and this information it is saying, right, two parallel lines if and only if they have the same slope. It is saying return the number of unique horizontal trapezoid that can be formed by choosing any four distinct points from the points, and it may be larger, so you just take the modulo. Okay, means a horizontal trapezoid is defined as a quadrilateral 4 points as we have given here, and it has at least one pair of horizontal side. So you can see one pair of horizontal sides we have, meaning the two segments that are parallel to the x-axis. You can see one segment is this parallel to x-axis, we'll do here, right? So this is the x-axis. So x-axis we have 1 2, and then another we have from 2 to 3, right? So these two are the parallel to the x-axis in the same y value, right? Can we say that? Means you need to count all the unique trapezoids that can be formed from the points where both horizontal segments are on the different levels, we can say different y levels, right? So this level at y is 0 and this level of y is 2, we can say 0 to 2, right? So the y levels will be different, but both are horizontal segments, we can say that. Okay, so if you'll zoom out, as you can see, there is multiple trapezoids here, right? And we have given like this. Oh, so okay, so let's think that the point we have given is, the very first is 1 0, right? Then what we have given is 2 0 3 0 2 2 and 3 2. These are the points we have given, right, in the this one, right? These are the points. So when y equal to 2, can we say that this is at 2 2? What is we have? 2 comma 2, and another is at here 3 and 2. Can we say that? And 3 and 2, right? So if we'll connect these 2 points, right, we can say at y equal to 2, two side is horizontal, right? Horizontal sides, how many horizontals are there? 2 sides, we can say that 2 side. Can we say that? Then we'll say when y is equal to 0, we have at this time we have at 1 0, and another we have is 2 0, and another we have 3 0. So there is bottom side, right? So from here, then we can say from here and then from here, right? So from, let's suppose this side and this side, can we say that? So this is the bottom side and this is the top side, right? So this top side and this bottom side we can say we have here, right? So 2 sides we have. Now we have to choose any 2 points from y equal to 2, means the top line. Means top line we have what? See, if we'll take 2 2, we will get 1 pair, right? We know that combination, what do you call, 2C2, right? Like that we are writing, it is coming 1 combination, right? So we'll get 1 pair here. Now we'll choose 2 points from y0, right? So we'll say, let's suppose 3, it means 2 we'll have to choose. Means when y is equal to 2, y equal to 0, right, we have to choose any 2 points. So if we'll choose any 2 points, means out of 3, how many points we have? 3 points we have. Out of 3 points we have to choose 2 points, means we get 3. NCN, you know, NCN, yeah, I remember NCN. So we'll take 3 pairs here, right? So we'll get like this. So total trapezoid, if we'll say between 1, we'll multiply it, right? 1 into what do you call 3, and what we will get here? We'll get 3, and that is why you will see answer is coming 3. Okay. So we can say to make the trapezoid, right, we have to qualify 2 things. First, we have to pick 2 points, right? We have to take 2 points from each side. From whenever we are taking either one of the y lines, we will take the 2 points we have to take, and it will form the horizontal base and the vertical base. Can we say that? So both horizontal and horizontal points, we can say, let's suppose this is horizontal edge, right, and this is we are taking from the second horizontal edge, right? We'll get this horizontal, right? We are getting this horizontal and this horizontal, right? Means we need two points. We need this point and this point, this point, this point, or this point, this point. Can we say that? Like that. Means total 4 points we need to form the trapezoid with the parallel horizontal side, okay? And that is why we are doing this one. Now here one thing is important to understand. What is our goal? Our goal only is to count all the combinations, right, that we have seen here. We are counting the combinations, right? The points should be greater than equal to 2, means we are taking the 2 points, right? And then we'll multiply, we are multiplying this one, right? And we are saying multiply the number of ways to form the horizontal segment on the different lines, either line this one or line this one, when y equal to 0 and y equal to 1, right? Means we have to combine all the horizontal lines whose points is greater than equal to 2, right? And we have to multiply them multiply the number of ways to form the horizontal segment on the different lines, we can say. So to group the very first step, what we need to do, let's understand what we should do here. Very first, you have to group the points with the y value. Can say that? We will group that. Then for each value, how many pairs we have. So pair of points we will form in the line. Let's suppose if you remember, let's suppose n minus not n minus 1, we can say c n and 2, we can say. Remember the combination thing, or that will come out n into n minus 1 by 2, right? So this is the mathematical formula we have to find the what do you call, how many points of point we can get from how many pairs of points we will find, right? And to find that, we will use this formula, right? Means very first what we will do, we'll group the points and will form their values. Can we say that? Then in the next step, what we will do, for each value we'll compute how many pairs of points can be formed on that line, and for this we will use this formula and you will calculate this, right? Now once you will have the pairs, now for every pair of y lines, what you need to do, you need the trapezoid, right? Trapezoid, you will see the spelling. So trapezoid is nothing but what? The pair of line 1 into pair of line 2. Can we say that? We will do multiply, right? Once you will have, just do the combination, add all combinations. Can we say that, right? So that we have to also check, we avoid what you call of n square, right? Because it will take the loops, right? And for that you have to implement some mathematical formula. Let's suppose, what is the formula is there? So let's suppose you want to find the total. Can I say that? So if you remember, there is a formula, this one, right, for the pairs, and we'll take 2, means this is the formula will avoid O of n square loop by using this identity, right? And so P is the number of pairs, we can say here, right, at a given line. So if you talk about the complexity, it will take what? O of n complexity of n, because O of n will take to group the y values, right? Y values that we are grouping the very first, and then we compute the count, right? So it will take that time, but it is only efficient for even 10 to the power, what was that? It was 7, right? You can say these points. If it is more than this, then it is not efficient. Okay, so this is the constraint we have given. I think you will understand the code, but do not try brute force approach. Try all the combinations, right? If you try all the combination, let's suppose we have C, N and 4, right? So you will try to check all the combination, right? It will take at least for 2 horizontal sides, and it will become what? O of n to the power 4, right? And that is not worthy, right? You can take O of n square, but it is not worthy to take all the combinations here, right? So geometry based scanning will do. So it will take f n of n square log n, right? Because we will pre-process and will check the slopes to find the parallel lines, right? But the optimized way that I'm talking about in this video, right, we'll optimize the combination that we have used here, and we'll count every pair by y levels, and then we'll smartly combine them, right? And that will take O of n times. I hope you understand. Let me know in the comment section that you are understanding or not. Okay, give me 1 second. Okay, so as you can see, what we have to do, let me zoom little bit. Okay, so very first step you have to do, you have to count the number of points at each level, right? And then you have to find the pairs, right? You have to calculate the number of pairs, and then how we are going to do, it's very easy. Just take, if count is greater than or equal to 2, we'll take the mod and we'll keep adding into the here. Okay, once you will get the total pairs and pair of square sum, right? What you need to do, you just apply this formula that I have told you, the total trapezoid things, sum of ps square minus sum of ps square, right? You remember, by divided by 2, right? So you have this value, you will apply this total here. How? You have the total pairs and total pair square sum, right? So you will get all this value like this, right? Just do the multiply, and you will have to take the mod also, right? You will get it, and then you will divide this into the modular formula, right? Modular inverse formula, you will apply this, and you will get here the total, and you will finally return this total. So you will tell what is this total formula, right? So this is a format little theorem, and because mod is prime number, so it is become very fast, because we are taking the inverse, right? You feel the fast modular inverse concept, we have to use this theorem, right? And for that you just need to do what? You will take the mod and you will pass the power of this value. Okay, and this is the power, you know, the power function you can create by your own, but this is the formula that we have to use here. Okay, So just pause this video and go through the concept. Do also try by yourself this formula. What is this formula, how it works, right? It will be better for you to understand. I'll put this code into the comment box so you can get it from there. Thank you guys, thank you for watching this video. I'll see you in the next one. Okay.